there were Atomic Energy Regulatory Board basically regulates all nuclear radiation related activities in India. Whether you have an X-ray machine or whether you have a nuclear power plant, all of them will be regulated by AERB for being safe for people and environment. Their target is very simple. You deal with any radiation and we want to make sure that you shall not harm the environment, you shall not harm the people. People includes us too. We are also people. So the administrative and regulatory mechanism of AERB have multi-tier reviews and so on and so forth. It's a lot of stuff. So the topic I'm going to talk about is computer-based systems, and that's why I said I'm happy some people will sympathize with me. We use computers in nuclear power plants, and these computer-based systems should be dependable. And how we define dependability is they should be, number one, safe. No matter what this computer does or does not do, the plant shall be safe. You cut off the power, plant shall be safe. It will not take an unsafe action, whether it's in good health or bad health. Now that's a tall order. Second thing, it should be correct. It should do, whatever it does should be correct at all times. Third thing, complete. The system should do everything that it's expected to do, and of course no more. Robust. It should be able to work under adverse situations. Operable. No good making something in which, like you put the steering wheel at the back of the car, no good. It has to be in the front, So somebody designs computer-based systems in which operator has to learn Java as well as Oracle or something. I think it's a useless computer. So it has to be operable. Operable by common people, should talk in their language, should not be open to operator errors. Very important. Maintainable. Typically we say it should be repairable within 30 minutes while the plant is online. That's a long call. One question. How many people here use PCs? Should be all. Has your PC ever failed? Anybody whose PC has never failed? No. How long did it take to repair it? 4 hours? Anybody whose PC got repaired in 4 hours? Ah, lucky man.
That was in US.
I'm sorry?
That was in US.
Oh, that was in US. Please come back to India. So, one day, many people. 2 days, I believe all. 30 minutes? Sorry. So, we got some difficult times here also. Upgradable. My plant is designed to run for 60 years. And this computer system is going to be sitting inside the plant. I cannot stop my plant for your wonderful computer. It should be upgradable in situ. I don't have the luxury of taking a laptop and bring it back. Sorry. It has to be there and it should be replaceable within bounded time frames. So upgradability. So there are so many restrictions that we need to put when we put computers in critical functions like nuclear power reactors or even aircraft and so on and so forth. There were no standards for these works till late 80s. Of course, as you know, software engineering itself became a subject of standards starting 1983 only. So only in the late 80s most of the IEEE standards came up. On control computers, there are very few standards. Only lately there are a lot more. How many people work in control systems here? Okay, so I think you should be with me. IEC is the agency which normally makes these standards. Of course, NC also does it. Now, we have been doing it. The designers of these systems therefore use ad hoc methods to achieve the required quality. The quality requirements don't go away. The method of achieving it, if there are not world standard, there is no world standard, then you got to figure it out. And very sparse knowledge base, because people don't talk like project management. so vociferously about this particular subject. And if somebody knows it, it's a trade secret, so he gives it. So very sparse knowledge base. You will get a lot of papers saying, I have done it, but how did you do it? Sorry, give me a job. So some examples of this kind of systems are reactor regulation system, alarm systems, protection systems, and these are fairly complex systems. You know, they are triplicated and with automatic failovers and whatnot. So what's the problem? We have to have a way of working on this. So we have some general methodology. There has to be a requirements definition. Requirements definition. Sometime back we heard that we know the requirements only when the project is over. I'm sorry, I don't have that luxury. If I were to say this is the computer after the reactor is built and you got to fit it, I'm sorry, it doesn't work. You have to fix the requirements right in the beginning, and if we commit mistake in requirements, it can be quite a nasty job. Quite a nasty job. The reactor doesn't get controlled. The plane doesn't take off rightly and you've got a big problems, right? So requirements definition. After which you take a decision, procurement or development, and then you go ahead to deploy. This is the critical cycle. While we do this job, we produce many documents, system specifications, architecture, hardware specifications, software requirements specification, user manual, and many, many more. Typically when we work in NPC, we produce something like 30 documents per system. Now, what's the next issue? Let me give some definitions here for those who are not from the field. Software quality assurance is, it involves monitoring, improving, ensuring that the process is being followed. Verification is the act of confirming that the results of an activity meet the objectives and requirements. And validation is confirming that a system fulfill its entirety, the requirement specifications as intended. So earlier we had made some statements like, you know, safe, correct, complete, etc. It should meet all those requirements. I have a question here. Is V&D different from audit then?
Yes.
How many people do software audits here? Anybody does software audit? Yep. You do the same things or different? Same things. It's different from V&D because audit merely confirms whether process has been followed. It does not look into whether the work products meet the specifications. It does not follow, it does not check whether the product meets the original requirements. Very different. So, what is independent V&D? Some term. V&D carried out by a independent agency. What is an independent agency? These things are important to us. You can have technical independence. I am not part of this project. I can have administrative independence. I do not report to the same boss. I can have financial independence. You don't pay my salary. The organization which is building system does not pay my salary, so I have financial independence. I can have political independence. I am from UN. I am not a part of India. So, you can have so many levels of independence. You need to choose the right level of independence. Independent V&D in our industry is considered to be the best available method to ensure dependability. Which degree of independence I shall apply will be case by case. Integrity is crucial in this game to meet the objective. Integrity is the word I use. Integrity of the reviewers of the organization which is involved in reviews. And universally, it is accepted to be difficult to implement and maintain. You can implement IVND, you will find sometime later it collapses. It becomes not dependable. You need to have controls over it again and again. Why we go through all these stories? because we simply can't afford an event in our plants. As simple as that. One event